Hello everybody, welcome to another presentation. Today we're going to be talking about the units of measure. Remember, go ahead and take notes while we're doing this because you can use those for our quizzes and for the test. So what does this number mean? A number is just, it could be anything. It could be 35 miles, it could be 35 apples, it could be 35 seconds. Um, if it doesn't have a label to it, if it doesn't have a unit behind it, numbers really are meaningless. So the reason why we use units is it gives meaning to what we're talking about. Again, alone 35 doesn't mean anything, but when we give it context, it begins to mean something. 35 feet, 35 years old, 35 students, or 35 apples. We call these descriptors units, okay? So first thing I want to talk a little bit about is how to get those units. How do we get 35? Where does that number randomly come from? Do we just estimate it, or do we use something more specific? In science, we try to be as specific as possible, and the basic thing that we use to measure something is a ruler. So there are two different rulers, and tell me what is different about those. First one, obviously, on top here, we have centimeters on top, and then we have inches on the bottom. On the bottom one here, we just have inches. Now notice you could read this is just longer than 1 inch, all right? Or so if this is inch, that's 1 1/16 of an inch, all right? And so that's how we break that down. We use fractions in standard, but in the metric system, we use decimals, which is a lot easier to read, convert, and to measure with. So in science, we typically just stay with the metric system. The American system is only used, it's called standard unit of measurement. It's used just in America. And it has all these random different sizes. A ton is 2,000 pounds. 1 pound consists of 16 ounces. Length, 5,280 feet is in a mile. A yard is 3 feet. A foot is 12 inches. So if we want to go from miles to inches, there's a lot of hoops we have to jump through. In volume, we use gallons. In 1 gallon, there's 4 quarts, and then you got 4 cups in a quart, or you got ounces. So there's a lot of different meanings. And in temperature, they use the degrees Fahrenheit. Metric system, I like a whole lot better. Everywhere else in the world uses the metric system, and it's based on the units of 10. Mass and weight are grams, length is meters, volume is liters, and temperature is in Celsius. On the bottom here, it says mass measures the weight of the amount of matter in an object. Length measures the distance, and then volume is how much space an object takes up. And these will matter a little bit in definitions and stuff when you take the test. So make sure you know those units of volume and stuff like that. The reason the metric system is so easy to know and to learn is because it is based on the power of 10. What that means is that as you go up or down, depending on if it's meters, centimeters, kilometers, it depends on which way you go in the unit of 10. So you'll notice down here you have this metric conversion using the stair-step method. If we're going from the benchmark, which is like, say we use meters, if we're going to increase the size, like larger than a meter, we can go up to a deca and a hecta, which we really don't use too much. We just go straight usually to the kilometers, which is 1,000 meters. Now, if we're going to go decimal to the right, which makes it smaller, we go down to deci, which we don't use much again, but we do use centimeters and we do use millimeters. Okay, and so that shows like the difference of how you can convert a meter to millimeters. There are 1,000 millimeters in 1 meter, just like there are 1,000 meters in 1 kilometer. Okay. So again, here are the rules. If when you're going from left to right, use some small, when you go from small units to big units, you move your decimal to the left. So if I'm going from a meter to a kilometer, I move it to the left, how many decimal points. And if I'm going from a big unit to a small unit, say a meter to millimeters, I move my decimal to the right. The other way is to use conversion, which is math, and it's a lot easier just to use our decimal place. For instance, 3 grams, if I want to take that to kilograms, well, a gram is small to big, so that means I'm going to move it over 3 decimal places. So it's 0.003 kilograms is 3 grams. And you'll have some practice doing this. If you want to pause it and work on it, you're more than welcome to. The next part I want to talk about is how to measure correctly. We talked about using a ruler or using different implements to get a measurement, but how do we get it correctly? You can just kind of throw a ruler up there and one person can measure 1 foot in 18 inches and the other person will look at it and go, no, it's 1 foot 16 inches. Well, how do we figure that out? Well, the things that we use are called accuracy and precision. Accuracy is how close a measured value is to the actual correct value, and precision is how close all the values are to each other. So think of it as in target shooting. You want to be accurate, which means you want to hit what you're shooting at. Okay, so the more accurate you are, the more likely you're going to hit the bullseye. Precision is how close all those shots cluster together. When I was teaching shooting and stuff in the military, we'd have guys that could hit the target, all the time, but bullets were all over the place. We want a tight group, because once you get a nice tight group, that means you as a person are doing all the right things, and then we just have to adjust the aim point of the weapon and then move that group over to the bullseye. So you'll see here there's low accuracy, low precision, low accuracy, high precision, high accuracy, low precision, and then high accuracy and high precision. When we're measuring things, we want to be in this group right here. We want high accuracy and high precision. So the second thing to know about accuracy and precision is when you're reading something, we want to report the measurements. How do you know that when you measure something, it's 6.34 centimeters? Well, we go with what's certainty, and then we go with an estimation. What is certain is that how far this nail extends past the last line that it is. So we know for a fact that this nail is 6 centimeters, and 1, 2, 3, all right, 6.3 for sure, but it's a little bit over 6.3, so we estimate. We go, it's about halfway, just less than halfway between the next dash. So we'll give that a 0.04, all right? So we use that. So again, metric system, we do not use fractions, okay? We use decimal places, and every basically line is another decimal over to the right, okay? And then you estimate that gap in between, and that's your last digit. So here we have another pencil. If we look at it, we know for a fact it's beyond 3 centimeters. So it's 3 point, well, there's 5, 0.6, 0.7, 0.8. All right, so we know for a fact it's 3.8 centimeters. Now our estimation, I'm going to say that's almost down there to like 0.07. So 3.87 would be a measurement there. Here's some practice you can use. You can look at the measurements. And if it's right on, we just go 5 centimeters. And if it's right, our estimation is 0.0, 5.0. That's where your significant numbers or significant digits come from in math. You may wonder sometimes, well, how the heck did they come up with so many, like 3 significant digits? That actually depends on the instrument you're using to measure it. A lot of the devices that we use in the classroom can get down to the thousandth of a meter. All right, that's 3 decimal places over. A lot of times we can just go to 2, which is like your normal ruler, but we'll just stick with what we have on the board here. So it takes a little bit of time, look at your measurements and go ahead and figure out that. Again, like I said before, the instrument determines the amount of precision of the data. If we look at our scale here, all right, we will notice that the highest number is hundreds. Well, it's at 0, so we go to the 60. So here's 60 grams. 61, 62 grams for sure. All right, 62.1234. 62.4 is the certain. We'll throw in an uncertainty if it's just past it, so we'll go 0.01. So that would be 62.41 grams. Okay, and you'll have plenty of practice using this in the classroom. The triple beam balance again is what we use in the class. So you can look at this again. There's the 260. 265, 265.567, all right, is the certain, and then the estimated is, let's say, 0.02, okay? So 265.72, and I'll let you do this last one on your own. So significant figures reflect precision by estimating our last digit. And when we talk about measuring volume, we use a graduated cylinder. But do you read the top or do you read the bottom? Okay, so we'll get into that right now. So read a graduated cylinder. The liquids in plastic and some glass containers, they curve at the edges. It basically, the liquid adhesion, the water and the liquid in there, will actually stick to the sides of your graduated cylinder, which means the middle section is this meniscus, is what that's called right here. It changes that instead of a flat line, it's now a curved line because all around the edges, they're sticking up on the sides, and the bottom here is the bottom of that curve. And that curve is called the meniscus, and when we measure it, we always want to measure on the bottom of the curve. Okay, and don't look at the thick line and go, well, I'm going to split that down the middle. Just go off the bottom of that thick line. Okay, that is the meniscus. So when we look at a meniscus, again, we want to make sure our eye is level with what we're reading. If you're standing above and looking down, all right, notice you'll have a lower reading. If it's up above you and you're holding it up to the light to try to see, you'll actually have a high reading because of the way your angle. So you want to make sure you're straight and level with that fluid. When you look across the fluid, the meniscus should not have a shadow to it. It should be straight across, and then you can see the bottom of the line correctly. All right, again, your eye should be level with the top of the liquid. Don't hold the graduated cylinder up in the air because you're going to shake and move around. Leave it on the desk. You just lower your face down to the level of the eye. Okay. Again, make sure you read the bottom of the meniscus. So here's some practice. It's pretty easy on this meniscus because it's just there at the bottom of the line. And think of the reading. So we're going to go up. That's how you read a graduate cylinder. There's 10, 20, 30 milliliters. Each one of these is 1, so 31, 2, 3, 4, 5, 36, and then we throw our estimated in there, 36.5 milliliters. And in this presentation and stuff like that, I have some more, and I will let you kind of click through and look at them. But again, the same thing is true. We're going to read at the bottom of the line, so it's not quite at the 43. I would say 42.9. Okay. Here it is again, the bottom of the line. Right, you could say that is equal with that 42.0. Okay, or sorry, 47. It's 2 above the 5. 47.0. And again, here it is. The bottom of the line is above the 61. So then you move that unit of estimation, and 61.2. Here again, we have 6 and 7. So 6, 1, 2, 3, 4, 5. Right above the 6 point. So we can go 6.60 milliliters.